Guys, Mr. Pistone, I'm going to review the equilibrium page, which is the CPO 5.2 page. Alright. So you have a ball here, and the objective on this whole worksheet is to keep things in equilibrium and to keep them balanced. So horizontally, those 12 Newton forces will balance one another. So to keep this object from accelerating, you'll need to apply a 7 Newton force to the northwest. So I'm going to try to use this notation when describing directions. Okay? Alrighty, on this one, to keep this table in balance, the forces up on the table need to be equal to the forces down on the table. So I'll write that equation over here. We'll say that force up needs to be equal to force down for this to stay balanced. So the forces up are 106, 106, 142, and then an unknown force. And then the unknown force, I'll just leave it as n. Actually, that n stands for newtons. We'll let that be our unknown variable. Forces down is 496, so 400 plus 96. Okay, if you sum these values here, you get 354 plus the unknown value is equal to 496. We're solving for n, so we'll subtract 354 from both sides. And then n, 496 minus 354, n will be equal to 142. So that's the missing force value. Okay, so just solving for an unknown variable will be the method to help us find a missing force. Okay, looking in the back. Okay, question 3 is very similar. I'm not going to do this one, but I'll show you just how to quickly set it up. This one is, instead of being force up is equal to force down, we have forces that are applied to the right need to be equal to forces that are applied to the left if this thing is going to be in equilibrium. So forces that are applied to the right are all of these over here. Okay, those are applied to the right. I know they're on the left side of the box, so we just want to clarify that. And then these forces over here are the forces that are applied to the left. So again, sum them on either side and solve for the missing value. Okay? And then question 4 is where I want to spend just a minute here because we have forces that are both horizontal and vertical. So what I would do is kind of set this up like this, and so we need to solve for the vertical direction and we need to solve for the missing forces in the horizontal direction. So vertically, or up and down, force up must be equal to force down. And then horizontally, or left to right, force applied to the left must be equal to force applied to the right. So I'm going to work the horizontal one because I want to focus on this right here, the fact that there's 2 unknown variables, and make sure we know what to do with that. So horizontally, forces applied to the left are the 25 Newton plus 25 Newton force. Okay, these 2 right here are applied to the left. And then these 3 forces are applied to the right. So we have an unknown, a 10, and another unknown. So this is equal to n plus 10 plus n. Okay, combine your like terms. We have 50 is equal to 10 plus, now what do you do with, if you have 2 unknowns? You just combine them, and so that's 2n. Okay, and then I'll leave it there for you to solve the rest. Okay, these last 2 questions require a little bit of creative thinking. Feel free to do a little bit of research to help solve those.